सो हेलो गाइस, हेलो एवरीवन। आज हम लोग डिस्कस करेंगे अबाउट कोऑर्डिनेट सिस्टम एंड वेलोसिटी एक्सप्रेशन, द एक्सप्रेशन ऑफ वेलोसिटी एंड एक्सप्रेशन इन डिफरेंट कोऑर्डिनेट सिस्टम। सो सबसे पहले क्या है कि कोऑर्डिनेट सिस्टम क्या है। ये बेसिक कोऑर्डिनेट सिस्टम का कंसेप्ट क्या है कि कोई भी पॉइंट को हम अगर हमें डिफाइन करना हो इन स्पेस, देन वी यूज अ सिस्टम, a mathematical set or frame of reference, whatever you say, which we say as the coordinate system. Physics में ये coordinate system बहुत important है quantity है, because in kinematics, while studying mechanics, when we deal with moving particles or when a particle is in motion, तो उसका कोई भी point में उसका position डिफाइन करना, इक्वेशन ऑफ मोशन सेटअप करने के लिए always we need a coordinate system. In this case also, now coordinate system very popular, एक very, there is a very popular coordinate system what we know is the Cartesian coordinate system, जो कि हम लोग we know that it's a x y z coordinate system where x y and z axes are mutually perpendicular to each other, like this. They are mutually perpendicular to each other, so this is a Cartesian coordinate system. Now, uh, other than Cartesian coordinate system, there are many coordinate systems. Actually, coordinate systems क्या है कि in physics, coordinate systems are so much important, and that's why it is required in each and every problems. It is required in each and every cases where analyzing different type of problems. So for that reason, क्या है कि कोऑर्डिनेट सिस्टम, सिर्फ कार्टेशियन कोऑर्डिनेट सिस्टम यूज करके ये देखा गया है कि सपोज देयर इज अ स्पेसिफिक टाइप ऑफ प्रॉब्लम where using Cartesian coordinate system, the problem became more difficult. Problem became more difficult in the sense the mathematics of the problem became more difficult. They became more tedious and cumbersome. So in such cases, it has been seen that the using a different coordinate system in place of Cartesian coordinate system at that particular point, the situation became much more easier. The problem became much more easier. इसलिए क्या है कि कार्टेशियन कोऑर्डिनेट सिस्टम के सिवाय और बहुत तरह के कोऑर्डिनेट सिस्टम्स होते हैं, और हम लोग पढ़ेंगे कि अलग अलग कोऑर्डिनेट सिस्टम में ये वेलोसिटी का या और एक्सेलरेशन का एक्सप्रेशन क्या क्या हो सकता है। तो उससे पहले चलो हम लोग बेसिक वेलोसिटी से शुरू करते हैं। हाँ, so in order to explain that, I am defining, it's sharing a screen. I hope the screen is visible to everyone. नाउ यहाँ पे देखो, कार्टेशियन कोऑर्डिनेट सिस्टम मैंने यूज किया है, और इस कार्टेशियन कोऑर्डिनेट सिस्टम में क्या है कि suppose a particle which was initially at point P at time t, now it is shifted to the point P dash. Now this P dash is a arc length, or you can say a chord length of delta L. और क्या है कि ये जो शिफ्ट हुआ है, इट इज द शिफ्ट has occurred in time delta t. So when the particle was at point P, the position vector of the particle was rt, and since r is a function of t, so rt equals to x I cap plus y j cap plus z k cap, where x, y, z are the coordinates. Now, and they are also the functions of time. They are also the functions of time, no doubt. They are no doubt also the functions of time. Uh, I am not unnecessary. I am not drawing mentioning this because this region will become clumsy. Now, ये डेल्टा टी टाइम में जो पार्टिकल जो है वो शिफ्ट किया फ्रॉम आर टी से आर टी प्लस डेल्टा टी में. सो चेंज इन पोजिशन वॉज आर टी प्लस डेल्टा टी माइनस आर टी. दिस इज द चेंज इन पोजिशन. सो रेट ऑफ चेंज ऑफ पोजिशन of the particle in time delta t can be defined in this particular way. Now, अगर सिचुएशन कुछ ऐसा हो कि if the limit delta t tends to zero, when the limit delta t tends to zero, then I can write limit delta t tends to zero, delta r by delta t equals to dr dt, which is defined as velocity by definition. Now, ये जो velocity है, now the velocity equals to dr dt, r is a function of time, ये सही है, लेकिन r is also a function of the path length l, क्योंकि हमने पहले ही डिस्कस किया what we have mentioned earlier, that if this is the path and this has a path, this has a particular path length, this is L. So, and P dash is delta L. So, this R is also a function of L. So, V equals to dr dt can be written as dr vector dl into dl dt. Now, dl dt is the rate of change of path in time, rate of change of path with time. Okay, that's okay. But what is DRT? What is DRTL? In order to define DRTL, ये क्या है कि DRTL जो है, this is nothing but uh, this vector, this DRDL is actually the ratio of the chord PP dash by arc PP dash. This is actually the ratio of the chord. If I consider this as it is an arc, so it's a curve. So if I consider a chord here, then it will be from P to P dash. If I consider a chord, then this chord is actually delta L, and the arc is actually this chord is actually delta R, and the arc is actually delta L. This arc is actually the curve is actually the delta L. The length of this curve, which is the arc, it is actually delta L, and the chord from P to P dash is actually delta R or dr. So chord PP dash by arc PP dash, this is actually DRDL. Now, as DRDL is occurring at that time when actually delta T tends to 0. Now, when delta T tends to 0, P dash approaches P. So, in such case, chord PP dash by arc PP dash will be tends to 1. This ratio will tend to 1. So, in this case, what we are getting that dr vector dl has a magnitude of 1, but it has a particular direction. So, I can define this dr vector dl as any unit vector tangential to the path length, so t cap. So, the velocity vector can be defined as now as this dl dt into t cap. So, which is actually small v, I can define dl dt as small v into t cap. So, velocity is actually v t cap. So, this is what the velocity is defined, and the direction of the velocity is along the direction of the motion of the particle, or rather tangential to the direction of motion of the particle. Now, from this concept, if I come to discuss about the acceleration, अगर हम लोग acceleration को define करना चाहे, so what acceleration is? Acceleration is nothing but it is dv dt. Now I can say that ddt equals to vt cap, and it must be mentioned that t cap is obviously the function of time, because यहाँ पे क्या है कि since it's a uh, abrupt curve, so with respect to time the direction of the unit vector is also changing. So ddt of vt cap, so it will be dv dt t cap plus v dt cap dt. I can write this thing. Now यहाँ से क्या हो सकता है, देखो कि dv dt t cap plus v dt cap dt. Now ये dt cap dt को अगर समझना है कि what this dt cap dt means, so in order to understand that, what I am doing, I am considering this particular diagram. Suppose the particle is moving along this path. So suppose initially the particle was at this point, now finally it has moved to this point. So if this is r of t, then eventually this will be r of t plus delta t. And suppose this is origin O. Now I am drawing further different origin. Suppose is a different origin. Let's suppose O dash. Okay. Now, from here, if I draw a tangent, this gives a direction at this particular point. So if I'm drawing a tangent over here, this will be a tangent here, and at this point, I'm getting a tangent like this. So if I take this as t and this is t dash cap, t cap and t dash cap are the tangential unit vector or the unit vector, and suppose this angle is delta theta, which is traversed in time delta t, and suppose I'm drawing a unit vector perpendicular to this unit vector. So since it's perpendicular to this unit vector, so I'm mentioning it as n cap and it is directed towards O dash. Now as delta t approaches or tends to 0, p dash approaches p. In such situation, O dash will approach O. And it's interesting that in such situation, if I find out delta t cap, if I want to find out delta t cap, so this can be found out easily. Delta t cap can be calculated by this way. Suppose this is the direction. Now this angle is delta theta and this one is delta t cap, then surely I can write delta theta equals mod of delta t cap by mod t cap, or delta t cap can be written as mod t cap delta theta into n cap, where n cap is the unit vector along this direction. How I can write this thing because the diagram showing that delta t cap and n cap will be parallel to each other where delta t approaches 0. So now limit delta t tends to 0 and when delta t tends to 0, or when delta L tends to 0, delta t cap by delta t. One more thing I should mention in this case, that pp dash, this pp dash equals to delta L, and I can from here delta theta equals to, so you can easily see that delta theta equals to, actually from this particular diagram, delta theta is equals to delta L by rho, where rho is this length, this one is rho. You can see that the radius of curvature of the path. So delta t cap by delta t, which is mod t cap delta theta n cap, fine, by delta t, sorry, to delta L, no, will be delta L. Delta L. Now, from this particular expression, delta L equals to rho delta theta. So if I use this now, mod of delta t cap is 1 because the unit vector. So limit delta L tends to 0, delta t cap by delta L equals to delta theta n cap by rho delta theta, which makes delta theta cancel out, so it will be n cap by rho. Now delta L tends to 0, delta t cap by delta L is nothing but it is dl dt, that is equals to n cap by rho. So what we got, dl dt, so, so it will be dt cap dl equals to n cap by rho. So I got the expression of dt cap dl, it is n cap by rho. Now, so this was my ultimate velocity expression, dv dt t cap plus v dt cap dt. So now, using now dt cap dt is written as d t cap dt equals to dt cap dl into dl dt. Now dt cap dl is written here. Okay, dt cap dl. So dt cap dl is n cap by rho, and dl dt is v. So it is v n cap by rho. So now, if I use this expression of velocity, acceleration a equals to t cap dv dt plus v dt cap dt, we can write it will be dv dt t cap plus v into this v n cap 0, v into v n cap by rho. So the a will be in such case dv dt t cap plus v square by rho n cap. So now this is the expression of the acceleration when a particle is moving along a curve. Now, when the particle executes a motion along the straight line, that is rectilinear motion, when the particle moves in exact straight line, so in that case, the radius of curvature rho tends to infinity. As a result, the second term vanishes and we get a equals to simply v dv dt and t cap along the direction of the motion, tangential to the direction of the motion. But when a particle exhibits uniform circular motion, if the particle exhibits uniform circular motion, this was for straight line motion, uniform circular motion, then this quantity v dv dt along the tangent is equal to 0, and as a result, the second term survives. So this one. So in that case, acceleration a is given by v square by rho n cap, which is popularly known as the centripetal acceleration, where rho is the radius of curvature and n cap is directed along the radius of the curvature. So this we have defined the velocity and acceleration of a system in a Cartesian coordinate system, but there are different coordinate systems. So next lecture I will explain the uh, how the expressions of velocity and acceleration can be represented in different coordinate systems, and how they are much more familiar to understand the physics at that particular point. Thank you.